Alright, starting the stream. I got a new angle set up. Hopefully get some better lighting as let's do that. Alright. And ideally, I'll get some even better lighting as we keep going. Alright, so for Wednesday, we're going to keep applying the strategy pattern that we covered yesterday and try to do a little refactoring to our players and then switch over to our NPCs and monsters and see if we can apply the same pattern there. If we can't, if it doesn't make any sense, we'll double back on player and just keep adding complexity until we hit our limit. But first, while I'm letting the stream warm up, I'm going to get an idea on paper that's a few weeks ahead, but I think if I don't get it out, I'm just going to forget about it. So, if we go into our, and I'll close everything, but I'll close everything. Let's go into our program. So right now, we've got a factory pattern, and we've got a strategy pattern. Factory pattern is creational, and strategy pattern is behavioral. Next week we'll do a structural pattern and see where we can apply that. And most things that you model, whether you explicitly call it structural, behavioral, or creational, is usually going to have one of those three patterns. You're going to want to have a very clear way of creating objects, a very clear way of structuring them, and a very clear way of having them behave. But right now, this is very messy. It's very procedural. We're just creating things and having them do whatever they can just to kind of see some output. But I want to take a second at the beginning of this stream to think about our environment. Eventually we're going to create a game engine that's going to allow all of these things to interact via an API that's going to keep track and persist and maintain state and all that good stuff. So for an environment, and this game probably won't win any awards, but it's great to get back to this kind of first concept or first principle of what does it mean to create a world? What does it mean to create a player? So, for the map, I'm going with a very basic multidimensional array. And I'm just calling it a sheet. And I'm going to keep track of rooms via dictionary. So you can imagine that if this sheet, the standard side for every sheet was return new, double int array, of 20 by 20 or whatever have you. So if every sheet was 20 by 20, then you'd have a coordinate. You'd have an x and a y. And so in room at column 16, row 5, you'd want to keep track of what's in that room. And so then instead of my room, I started thinking, okay, well, I'm going to have a room key, which is just the x and y coordinate. And then I'm going to have a list of players, list of monsters, list of items. Let's change that a little. And thinking. Let's say for any room, you're going to have a key, and then you're also going to have a IEnumerable of room objects. we don't quite know what a room object is yet, so let's go ahead and make one. Let's say the public class room object for our instantiation properties for the things that belong to this room object. We want it to be might end up being protected, but for right now, let's just say that it's a type. Call that object. We'll stick with type. So a room object consists of the type, which ended up being the derived type. So player, NPC, whatever have you. And game object is going to be our very base object that all things in the game derive from. And so come back over to room. So now what this is going to let us do is simplify the room, lighten up the class, and allow us to introduce a bit later on the concept of rendering, right? So we can keep track of the entire world, all the game objects, in all the rooms. And then when you look at a room, we can loop through that room's game objects and cast or render out what should go where. So instead of carrying around this heavy, explicit definition of what's in every room at all times, we're only going to render or cast when we need to. I think the design pattern we're going to use when we get here is going to be the builder, but we'll see. But for right now, I just wanted to get this idea on paper, get it out of my head so I don't lose it. So a grid is going to consist of a sheet and then a dictionary of room keys and then what's in that room. So that's super crazy. And then inside a room we'll have the X and Y coordinate and a list of room objects, which is their game objects and their types. Alright, so now that the environment is out of my brain and it's over here for safekeeping, presumably when we come back to it in a few weeks to actually make use of it, I'll remember the reason for the madness. Alright. So going back into our player. Yesterday let's do a commit real fast because it looks like we have some untracked files. Untracked files, that's just 29 of them. Sure. Okay. Alright, so now we're all synced up. Looks like everything is being tracked accordingly. So yesterday at the end of the stream, we went into our player, which used to be a straightforward factory pattern. We left the factory intact as far as the API call goes, and we left the switch statement intact. But for the actual instantiation of a new player, instead of saying new army vet, new whatever, we made player an abstraction, and we made the concept of army vet or the class of the player a behavior. So that was our refactor. We went through and we did kind of a complete thought on how that would change the factory pattern, not necessarily in its implementation, but kind of its behind the scenes. So I think the first thing we're going to do is we're going to play around with one of the benefits of using a strategy here. So we've got this new army vet, which is a behavior, so let's go take a look at that. And all new army vet is a list of implemented methods from the iPlayer action strategy. Take a look at that and refresh ourselves. We're just an interface, so no inherited behavior, just a contract. Let's go ahead and close that out. Now, there's nothing linking this behavior directly to a player. It's going to house an algorithm that will perform differently per class, per action. So what if we did this? This is already static. Let's do a static dictionary. And let's do, for the key of that dictionary, we'll do player type. And for the value, we're going to do iPlayer action strategy. We'll call this player strategy map. Equals, and we'll let ReSharper help us out with a new statement. Okay, it's getting kind of big, so let's go ahead and bring this down a line. Alright, so we're going to create a player strategy map, and then we will use an object initializer. And then for the player type of army vet, we'll say new army vet. Right? This is going to look kind of hairy, I think, for a second, but we'll see. And then we'll make another dictionary entry for player types, carpenter, new carpenter. Then player types, mechanic, new mechanic. Player types, medic, new medic. Sir Bug-A-Lot, yes, I am using a standing desk. So, and I'm playing around with it right now. And it's a small table on top of a regular desk. And I still haven't figured out the levels for my keyboard. I was using an Xbox carton before, and I just have it up by the monitor. But I just ordered a nicer mouse and a nice ergonomic keyboard, and we're getting there. Trying to save my wrists and save my back from, coding 8 hours a day and then a bit in the evenings. So yeah, instead of paying $3-4 or whatever have you, I just decided to follow the do-it-yourself folks and figure out what I can find at a thrift store. All right, so next one is politician and new politician. All right, so the method of this madness is because I have abstracted out this behavior and it's not reliant on any instance variables, meaning that it's not directly tied to the player. I can abstract that into a dictionary, make it static. So instead of every player carrying around a copy of these behaviors, I'm going to put them in one place, and then by putting them in a dictionary, they become a reference. So hopefully I won't suffer any performance costs, or I should actually get some performance benefits from doing it this way. But the real benefit is going to be to showcase how the pattern allows us to clean up a typical factory pattern into something a little cleaner. So instead of doing the switch statement, which is what I would do if I had a tightly coupled implementation of player, where I needed every time to pass in these dependencies and to construct this very complex player. That's not the direction I'm going. What I want to do is make a very lightweight player that can have pointers to various different behaviors that it can draw from. So I'm instantiating these into my static object, and it will remain in scope for the life of this class. And to make the class static, then it should remain in the scope for the life of the application domain. So we won't be needlessly creating new army vets, carpenters, mechanics, whatever have you. When we come over to program and we instantiate our game engine, we can with that one-time cost of bringing the game engine online, take all the resources and put them someplace where they can be reused. So then inside the create statement, to make this a little bit cleaner, I am just going to say return new player, pass in the name, the player type, and then where I would have passed in a where I would have passed in a brand new strategy before, I am going to call the dictionary for player strategy map, access the index for this player type, and I'm done. Which makes all this code redundant. So we remove that. This becomes a new factory. So it's still a factory, it's just a smarter factory. Because as we add in new behaviors and attach them to players on creation, so we might have subtypes, we might have alignments of evil, neutral, good, whatever have you, that bring with them their own behaviors. We can create new maps for those strategies, and while those maps, and we'll pull it down here for the sake of Alright, so while those maps will grow and grow and grow and grow and grow, our call will stay the same, minus the new parameters, right? It's still going to be this one line that we can use to create the player. Alright, so that's one of the benefits of taking that strategy and separating it from our abstraction, or from our implementation being the player. And we'll compare that to our NPC factory. So this is our very traditional switch statement on an enum. It's going to return back a new object, a new implementation. And then this is our player factory, which, now that we've abstracted out the strategies, looks a bit different. This is hopefully going to be very helpful to be able to see the factory pattern being implemented in different ways and how it grows and gets refactored as we start layering on different design patterns. Okay. And again, that changes nothing in terms of our API. So any calls that we had here should still work. So the build succeeded. Let's start. we go through our calls we made yesterday. I'm just going to step through. I won't read through it again, but everything still works, no new bugs. We're able to, again, refactor and refine the code behind the scenes without suffering any new points of failure. All right, so let's dig a little bit deeper into our player and try to actually expand on some of these behaviors that we work so hard for. Okay. So, damage, we don't know where damage came from. Presumably it came from a monster of some kind. Let's look at heal first. Now, we assigned heal a value of 20, but Beth moves to heal Morgan. Ideally, that value would be something that Morgan generates. I'm sorry, that Beth generates from her role as being a medic. So let's go into our medic class. Okay. Alright, so for our concept of heal, it's changed up a little bit. Let's go to declaration on it. Let's make a distinction between things that we can do to other people and things that happen to us. I'm going to start here. We'll say that heal returns a double. And takes in nothing. I don't know if that's going to be too confusing. Let's just see it and put our eyes on it. We might change the wording on this heal being the one that's done to us versus the one that we provide somebody else. And presumably attack would be the same way. You'll hear my dog chewing on a bone in the background. If you can, I will gently encourage him out of the room. Okay, so we got these kind of sister methods where attack is something that we deal out, take damage is something we receive, which we should probably figure out a better way to write this so there's some distinction. Okay, so let's make sure that plays through everywhere we want it to. Let's go back into the medic. We need to change everywhere that we have this guy to double. And then we need to put in a double heal. The refactoring, just don't quit. Okay. But it's good. Some people would argue this is why you get one class done the way you want it before you move on to your grunt work of pushing it out to other implementations. That person would be very wise, and I don't question them. I thank them and their hindsight wisdom, but we didn't do that, so I had to copy and paste a few times. All right, so now everyone has the ability to dish out damage and also dish out some love. Let's go into our player abstraction. And we want to give that same ability to our abstraction. So we have attack. We want to make this a double. Let's go and copy that down here. Not copy, but public override double heal. Oops. And then we're going to return action strategy dot heal. Return action strategy attack. Fair point. So let's go in our base actor first. So this is complaining because we are hiding something. And we are, because we said that we want all actors, whether they are monsters or players, to be able to dish out some damage. And we do. We want, I don't know if I want all actors to be able to heal. Yeah, that's fine. Monsters should be able to heal themselves. I mean, they have rights. Okay, so we need to keep on down the inheritance chain where, oops, hang on, let me back it up. I actor. So we're changing our contract now. Thank you, member 7. It is, member 7 says that's well organized. It is. It's, well, I mean, it hopes to be, and it hopes to stay that way. Part of implementing our design patterns is to show how we can keep costs of maintenance flat, not just in this, but in anything we model, so that there's an adage in software development, I'm sure everything else, but it's that changes to the system become exponentially more expensive as the system gains complexity. So as very, very smart developers, the value add we want to bring to the texture is to say that we flatten that cost, that adding complexity shouldn't make cost increase exponentially, or it should increase technical debt. Well, hello to you, Testy. That's interesting. Testy 123444321. I'm going to assume there's a story behind that, and if there isn't, you have an opportunity to write some, I don't even know what, fan fiction, I guess, but about the origins of your, maybe like a prison tattoo, maybe it's like your prison number. I don't know. That's your job. You can figure out what that means. Okay, so let's go back over to our what? Where were we? Let's close out mechanic, carpenter. We just want the medic. Okay, so why don't we do this? Just to keep our algorithm system simple, but also to have one. The whole point of encapsulating our strategies away from our abstraction is so that we can take these algorithms, refine them, and keep them separate from our implementation. So We just want to say that a medic heals for 20. Nothing complicated. Hello, Testy from Brazil. Yeah, man. Awesome. It's the gift that keeps on giving, learning how to code. There's definitely a talent suck everywhere that I've ever been for decent developers. And it's really hard to teach, surprisingly enough. So you're definitely on the right track. You got better resources available to you now than I did when I was coming up. So glad to have you, and I hope this helps. I'll probably be posting some links to videos that I really enjoy. There's a few beginner series in C# that would help people get up to the design pattern level pretty quickly. So now that I know there's some folks out there who are definitely just getting started, I might throw those into the channel. Okay, so a medic always heals for 20. I think that's fair. We don't really have any kind of base rules. We don't really have any canon for the game to operate under. But let's just go ahead and implement the idea of healing for all of our players. So an army vet only heals for... Again, I'm an army vet, so I like to believe that they have a well-rounded skill set. So let's say that an army vet heals for 10. Not quite a medic, but they got some first aid training. They can do some stuff. All right, carpenter. Carpenters work with tools. They're around construction sites. You know, maybe they don't have the same level of training as an army vet or a medic, but they can do something, right? They can turn a 5. Mechanic. What kind of mechanic heal for? You know what? Same thing. They're around heavy machineries and things, right? They know where the first aid kit is. They can do a 5 as well. All right, let's do the politician. I've said this before, and it's gonna seem like I'm picking on politicians, and I'm not. But I really do believe they're worthless in a lot of ways. So. Let's just say, you know what? If a politician tries to help you, they're gonna do more harm than good. So a politician heals for -4. Don't let a politician treat your wounds. Okay, so that's our super simple algorithm. Maybe it's good to make it this simple to show that an algorithm doesn't have to be something that's crazy and complicated. It can be anything that answers, a question using some intelligence. So, -4. Okay. This all looks fine. All right, so what does that mean? What does that mean for our game? Let's go back over our program. Well, it should mean that we don't have to guess anymore about, or just we don't have to cheat. We know what a medic can heal for. So let's have Morgan answer that question for us. Oh wait, Beth. Who's Beth? Yes, Beth is the medic. If we could have Gary do it and create a big old bloody mess. Oops. All right, so this thing wants a double because we didn't expose our actual healing method to this contract. So let's do 2 things here. First, let's remove the confusion of heal. Let's go all the way back down the line. iActor. So monsters might be able to heal. Let's add that there. Base actor looks good. Base game object, yes. So we come down to the root of our game object. Pretty sure I'm also a carpenter or someone in my family is. Angry masturbator, I'm going to leave that question to the imagination. Let's call this restore health. And next, you know what? Let's go ahead and use sharper for this. Let's take this guy, refactor, rename, restore health. I'm absolutely going to send JetBrains, the maker of ReSharp, an email and try to get a free license for all of this great publicity I'm doing. So, restore health. Cool. Okay. So I renamed that to restore health. And so my base actor, which I'm applying to both monsters and characters. The three, they can do a bunch of things, but three we're concerned with is attack, move, and heal. So this should, you can start to see kind of a battle taking shape, right? And you can start to see this idea of other behaviors that we can engineer. So what happens when a monster gets attacked? And what happens when a monster's health falls below a certain point? If they have the ability, they should heal themselves. It's not crazy artificial intelligence. That's just a very basic condition that we can program into a behavior and say, hey, every time you get hit, check to see what your health is. And if it's below this amount, cast a heal on yourself, buddy. You are not a victim. There's that movie Wreck-It Ralph when they have that chant where it says, I'm a bad guy, but I'm not a bad guy. All right, let's give our monsters that benefit of the doubt. Where do some self-care. Let's not derive you of that ability. Angry masturbator, like who would put a carpenter in the game otherwise? You don't know. You don't know, man. There could be tons of reasons. Well, I don't have a good one right now, but there could be tons of reasons why I put a carpenter into a game. Alright, so let's see. Where were we? Oh, that's right. We're going to expose this heal. Let's go back to our factory, our player factory. So we're returning a contract of iPlayer. So whatever returns going to satisfy this contract. And conversely, it's a knife that cuts both ways, we're only going to have access to things that are defined in this contract. So let's go. We don't have that here. We also have access to things that are defined in iActor. Let's go there. Boom. And iGame object. Cool. All right. So this. Just hopefully that'll work. Let's see what happens. And if we don't get what we want, then we will keep digging. I mean, we made this mess. There we go. So now we've got access to the heal. And oh no. Oh, hang on. Video went down. In the Twitch channel, folks are reporting that Twitch says the stream is unavailable. Let's see what happens.